In example 5, we're going to answer some questions about geometric sequences. In A, we're asked to consider the sequence 200, 150, 25, etc. And we want to know the value of the 10th term in the sequence. There's a few ways we could do this. We could actually calculate out the 5th one, the 6th one, the 7th one, and so on. I'm going to show you a little bit more elegant of a solution. So the first term is 200. R for this one is dividing by 2 or multiplying by 1/2. And excuse me, I should have said the pattern is divide by 2 or multiply by 1/2. But R has to be 1/2. It's only what you multiply by. And that'll be raised to the n minus 1. If we want to find the value of the 10th term, then all we need to do is substitute 10 in for n. We're going to use our calculator. 200 times 1/2, and 10 minus 1 is 9. You need to be very careful if your calculator doesn't have the software that puts the exponent up in this position. If it doesn't and you want to type in 10 minus 1, you got to type your little hat button here, the caret button, and then you have to absolutely make sure that you put in parentheses the 10 minus 1. If not, you'll get the wrong answer. So it looks like this one is 0.3906, 0625. Okay. In part B, we want to know A sub 14 for the following sequence. Well, A sub 14 is going to be A sub 1, which is 2, times R, and I think R is 3. We multiply by 3 each time. All raised to the 14 minus 1 power. When we type this into our calculator, we can just do 2 times 3 to the 13th power, that's 14 minus 1, and see what we get. You can see here that the value of the 14th term in this geometric sequence is going to be 3,188,646. In part C, we're going to find the missing term in the sequence. We're going to write a rule that describes this sequence and verify that your number is correct. So we multiply by 3, multiply by 3, multiply by 3. Another multiplication by 3 gets us to 162. We could double check here and just do 162 times 3. We should get 486. And that's true, so that's good. We'll write a rule here, A sub n is equal to A sub 1 times R to the n minus 1 power. Same thing we used here previously. It's actually the same sequence. Well, this is the 5th term here, so what we want to do to verify is just use our formula, and we'll just type this in the calculator. So it's 2 times 3 to the 4th power. 5 minus 1 is 4. And we get 162, which is the value of the 5th term.